This is the second part of section 4.4, factoring polynomials. This is a very short section, short video. The one topic in this video is the idea of the factor theorem. The factor theorem says a polynomial f of x has a factor x minus k if and only if the remainder when f of x is divided by x minus k is 0. So let's think about what a factor is. So if I listed out the factors of 12, that would be 1, 2, 3, 4, 6, and 12. The reason those are factors is because when we divide 12 divided by 1, the remainder is 0. So this would be 12 remainder 0. If I took 12 and divided it by 3, that would be 4 remainder 0. Or if I took 12 divided by 6, that would be 2 remainder 0. Okay, so the reason they're called factors is because the remainder is 0. We can apply that same thought or that same theory to polynomials. So the question is going to say, determine whether the given binomial is a factor of f of x. So what they're going to get, or what you're going to get, you're going to get something that looks like this. They're going to give you, or you'll be given f of x is equal to something like x squared plus 2x minus 4, and then they will give you a factor x minus 2. Now, if the factor, or if the binomial, if this is indeed a factor of f of x, the remainder should be 0. If you get a remainder anything other than 0, then it's not going to be a factor. Okay, so we can use synthetic division because we're dividing by x minus 2. Okay, so our coefficients go in the middle, 1, 2, negative 4. The number on the outside is the opposite of the number in our factor, x minus 2. Okay, and let's just do our synthetic division. So we'll bring down our leading coefficient, multiply by that number out to the left. 1 times 2 is 2. Add straight down. 2 plus 2 is, that's 4. And then multiply by the number again out front. So we'll take 4 times 2, that is 8. Add straight down. Negative 4 plus 8 is positive 4. This was my answer. Is x plus 2 a factor of x squared plus 2x minus 4? The answer is no. The remainder is not 0. So we could say the remainder, and I'm out of room there, is not 0. Okay, so since the remainder is not 0, x minus 2 is not a factor of f of x. Let's try one here, number 2. This one probably will be. So we'll have f of x is equal to, let's have 3x to the 4th plus 15x cubed minus x squared plus 25, and then the factor that will be given is x plus 5. So again, we'll need our L, our synthetic division, coefficients inside, 3, 15, negative 1. Now I don't have an x term, so I need a 0 there, and then finally 25. And then let's see, the number out to the front is the opposite of the number in the binomial, so negative 5 goes out there, and we'll just run through our synthetic division. So bring down your leading coefficient, multiply by that number out front. 3 times negative 5 is negative 15. Add straight down, that's 0. That's a good start. Let's keep going though. 0 times negative 5 is 0. Add straight down, that gives me negative 1. Negative 1 times negative 5 is positive 5. Add straight down, 0 plus 5 is 5. Multiply 5 times negative 5, that's negative 25. Ooh, that's a really good number, because what happens, we get 0 on the end. So is x plus 5 a factor of f of x? Yes. Okay, yes. We could say that f of negative 5, because really, think about synthetic substitution, gives me a remainder of 0. So x plus 5 is a factor because when I plug in negative 5 into this, I get an answer of 0. All right, the last example here says show that the given binomial is a factor of f of x and then factor f of x completely. So let me give you the f of x. F of x is equal to, we're going to have x to the 4th plus 3x to the 3rd minus x minus 3. And we need to show that the binomial x plus 3 is a factor, and then we're going to factor it completely. So what we're going to do, we're going to start with synthetic division. Coefficients in the middle, 1, 3. I don't have an x squared term, so that's 0. Negative 1, negative 3. The number out front, the opposite of the number in the binomial, negative 3. And let's go from there and do our synthetic division. So we'll have 1. 1 times negative 3 is negative 3. That leaves me with 0 underneath. 0 times negative 3 is still 0. 0 plus 0, that's 0. 0 times negative 3, still 0. Negative 1 plus 0 is negative 1. Negative 1 times negative 3 is positive 3. Negative 3 plus 3 is 0. So it is, in fact, a factor, okay, because we got a remainder of 0. Now, if you remember, this is x to the fourth. So when it comes down a row, now it's x to the third power. This was x to the third, so now this is x squared. This will be x. This is my constant term, and then my remainder. So what I've got left then is x cubed. Well, that's just x cubed minus 1, and then don't forget x plus 3 out in front, okay? From the previous video, x cubed minus 1, that is a difference of cubes. X cubed is a perfect cube, 1 is a perfect cube, which means we can break down x cubed minus 1. So remember the difference of cubes pattern. We start with a short one, then we have a long one. We'll have x plus 3 out front. That's x plus 3, okay? Remember, x cubed, the first term, first binomial in our factoring, these are the cube roots of these two numbers. Okay, so x cubed, the cube root of that is x. The cube root of 1 is 1. The sign, the first sign always matches, so it's going to be x minus 1. The first term in our longer polynomial is the square of this, so x squared is just x squared, obviously. Next sign is always the opposite, so it's going to be plus this time. We need to multiply x times 1, in this case, x times 1. That is just x. And then the third term, well, actually the sign is always plus, the last sign. This third term is the second term in the binomial squared. So we're going to take 1 squared, and that would be 1. Now, this part, the difference of cubes, that is factored completely. That cannot be broken down any farther. We're not going to be able to break this part down, that x squared plus x plus 1. Once we get to here, this is as factored as far as we can go. At least the stuff in purple is. The line here in red, x plus 3, that's a degree 1 polynomial. That can't be broken down any farther either. This right here is your final answer, x plus 3 times x minus 1 times x squared plus x plus 1. Okay? It told you to show that the given binomial is a factor. We've done that because our remainder is 0. These numbers down here give us the coefficient of the remainder, or what we multiply by, because if I took x cubed minus 1 times x plus 3, what would end up happening is I would get right back to here, x to the fourth plus 3x cubed minus x minus 3, but that's not the point. I want to go down even farther. Okay, x cubed minus 1 can be broken down into this. That's the difference of cubes pattern, and then we still have the x plus 3. This is degree 1, unfactorable. We are done. We have factored it completely.